Next is time independent Schrodinger wave equation. It is important derivation your exam point of view. Okay, so based on the de Broglie idea of matter waves, according to de Broglie, based on the de Broglie idea, Schrodinger developed a mathematical theory. According to de Broglie theory, a particle moving with velocity v associated with its wave of wavelength. The de Broglie wavelength expression is lambda is equal to h by p, where h is Planck's constant, p is momentum of the particle. So this is from de Broglie wavelength equation. It is called it as equation 1, where p is momentum. Momentum relation is, that is p is equal to mv, where m is mass of the particle, v is velocity of the particle. Okay, so next is the wave function describing the de Broglie wave considering traveling in positive x direction. Okay, see, when the wave traveling with a wave is moving along positive x direction, this wave is described the wave function, that is can be written as, it is mathematical expression is total wave function psi is equal to a e power I kx minus omega t. This equation is represent the wave function describing the de Broglie wave. Okay, call it as equation 2. Next is, in the equation there is have two term. One is position term and also time term. There is take a separate term, the space independent part in equation 2, that can be represented as small wave function psi is equal to a e power I kx. So there is write only this term. This is represent only the position part. Okay, it does not depend upon the time. Next, equation 2 becomes, that is total wave function psi is equal to small wave function e power minus I omega t. This is the second term of the above equation, that is equation 3. Next is, let us take differentiate above equation with respect to x. Okay, how many takes you take differentiate, that is twice. So differentiate total wave function twice with respect to x. Since we have, there is equation, differentiate equation is equation 4. Next is same equation 3, again differentiate total wave function twice with respect to t. Okay, here x, here t. We have above equation is, that is equation 5. Okay, equation 4 and equation 5, this is a differentiated term from equation 3. So next we have consider the equation for a traveling wave, as this is a traveling wave equation, considered equation. Okay, how it comes? Okay, how it comes, don't take any explanation, any derivation about this equation, because it is a standard equation in a wave, in a traveling wave. Okay, so there is, why is the wave is displaced along y direction. This is taken as y axis, this is taken along x axis. The wave is displaced along y direction. Okay, there is, in the wave, particle is there, particle is moving with a velocity v. Okay, that is 1 by v square. This is standard equation, that is keep in your mind. And this equation, that is right in terms of the wave function, that is instead of y, there is to be take total wave function xi. only change in the term total wave function instead of y. So this equation is 6. Okay, next, using this equation 6, continue the derivation. Above equation represent wave propagating along x-axis with velocity v, and total wave function psi is the displacement at the instant of time t. Next, you take some simplification. Equation 4, equation 5 and equation 6. We get this equation. Just you write it, just you substitute where equation 5 this term and equation 6 that it is substitute in equation 6. Sorry, equation 4 and equation 5 substitute in equation 4. Next it comes d square psi by dx square is equal to minus omega square by v square psi. Okay, so next is, if lambda and v are the frequency and wavelengths of the wave, your omega relation is 2 pi nu and v is equal to nu lambda. Okay, next is, in the previous equation there is to be substitute omega and v, you will get this equation, and this equation 1 by lambda square, this 1 by lambda square write in terms of 1 by lambda square, remaining term write in the left side term, so that is equation 7. For a particle of mass m moving with velocity v, so every particle moving with a velocity v, the kinetic, it represents kinetic energy. That kinetic energy equation is of mv square. You know that. Multiplying and dividing by m in the right side term, you will get m square v square by 2m. So already I told you that is momentum of the particle p is equal to mv. Here m square v square, simply how write p square, then divided by 2m, that is equation 8. It is moving particle kinetic energy equation. So next, in the beginning we get de Broglie wavelength expression, that is lambda is equal to h by p. But here a little bit changes in the equation 1, p is equal to h by lambda by substituting for p in equation 8. Next we have, that is kinetic energy is equal to p square by 2m 1 by lambda square. So 1 by lambda square already we got equation 7. So this equation 7 substitute in equation 9. So what happened here? Next it comes one more another equation, that is equation 10. Okay, so next is, kinetic energy and potential energy. So potential energy is represented by V. Therefore, take total energy of the moving particle, that is E is equal to kinetic energy plus potential energy. Kinetic energy equation already is got, that is minus h square by 8 pi square m is equal to E minus V. Take some simplification using given equation. Next finally you take time independent expression. This is expression is time independent schrodinger equation. So time independent means that is wave function depends only on the position, does not depend upon the time. So in the final expression there is no time term. Okay, this is how only the position term, d square psi by dx square. Okay, so this is time independent equation. It is important question your exam point of view, so do